One skill that you need to develop is looking at two molecules and deciding what the relationship between two molecules is. Whether they are the same, actually the same molecule, just drawn differently, or whether they are isomers. In that case of isomers, there's a couple different versions of isomers. There's constitutional isomers and the diastereomers. Later on, we'll learn another type called enantiomers, but right now let's just focus on constitutional isomers and diastereomers. First of all, let's talk about the same molecules. If you look at two structures, and they are conformations of each other, or they are resonance structures of each other, then they are the same molecule. Examples. These two structures. Both of them have the formula C4H10. Only difference is this one is in a syn conformation and this one is in an anti-conformation. And the way you relate the two to each other is just rotation about a carbon-carbon single bond. And you can rotate about carbon-carbon single bonds, so these two are just conformations. So these represent the same molecule. There are often different ways of drawing the same molecule. You could have them draw, such as if you have a chair conformation, here and here, these two represent the same molecule. So if you were to count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, carbons 1 and carbons 5 both have methyl groups in the up position. Sometimes being able to name a structure will help. Like this one, you could call 1,3-dimethyl cyclohexane. Notice I use 1,3 and not 1,5 because I wanted the lowest combination of numbers possible. Moreover, these methyl groups are in the same phase as each other, so that's cis. And this name also applies to this. So these are also the same. If you have molecules that can exist as resonance structures, such as electrons come down here, that these two structures also the same. So conformations and resonance structures are the same. Represent examples of molecules being the same. Now, constitutional isomers. Constitutional isomers they have the same molecular formula, but different connectivity. Another way to think about it is the sigma bonds, the sigma system is different. Example, that this molecule here, diethyl ether, spell that molecule correctly. This molecule is butanol. Both of them have the same formula, C4H10O. This has 3 hydrogens, 2 hydrogens, 2 hydrogens, 2 hydrogens, 1 hydrogen. 1 plus 2 is 3, 5, 6, 7, 8, 9, 10. 4 carbons, and oxygen. Both of them have the same formula. Now notice the connectivity is different. This has an oxygen between 2 carbons. This has an oxygen between an H and a carbon. Okay. Another example of a constitutional isomer of diethyl ether could be propyl ether, propyl methyl ether. Again, same formula, just a different bonding. The last type are diastereomers. And these are typically the hardest type to recognize. A diastereomer is an isomer, so same molecular formula, but it also has the same connectivity. So sigma system is the same. But what makes diastereomers different is they're different inter-atom distances. For the diastereomers we'll have for exam 1, these usually have a bond that cannot rotate cannot rotate a full 360 degrees. So bonds that don't rotate 360 degrees are things like double bonds, carbon-carbon double bonds. Such as here we have 2-butene. Both of them answer to the same name. They both have the same connectivity. The only difference between these is here in this example, this methyl group is further from this methyl group as these two methyl groups are. So oftentimes diastereomers have like cis or trans prefixes. Like this is trans, this is cis, or E or Z prefixes. Rings can also be a source of diastereomers. Like in this case, the 3 methyl groups are on the same face of the molecule. This one, the middle one's on the opposite face. Both of them answer to the name of 1,2,3 trimethyl cyclohexane. Okay, but on one you have the methyl groups on the same face. On the other one, 2 of the methyl groups on the same face. The other one's on the opposite face. Another example of a diastereomer of these two compounds could be this case right here. Here, 2 of them are on the same face, one's on the opposite face, but they're different from this one. So these are all diastereomers.